For our ME106 project, we chose to do an accessible dice tower. My name is Jasmine.
I am Isabel.
I'm Odin.
And I'm Shri.
And let's get started. Alright, so for our project, our purpose of creating a dice tower is to help with ensuring probability when it comes to dice rolling games, so this can help with gameplay fairness. And also, it can help with board games such as Dungeons and Dragons. And we also have four main goals in order to accomplish for this project. So for the first one is for our funnel, we wanted to be able to load 5 dice. And then we also have a button that when a user presses it, it's able to dispense 1 dice at a time. And we also have a camera that's able to read and count the die. And we also have a pusher that's able to push the dice off into the bucket from the viewing area.
For the mechanical design considerations, we made sure that this gear fins were at an angle in addition to a slope at the bottom of the tube so that the fins caught the dice at their rounded corners as opposed to their less rounded flat edges. We also had an asymmetrical funnel shape, and this is so if the dice are poured in, they do not reach the base of the funnel at the same time. Finally, we also have an easily slotting bucket. This bucket has a pin and slot so it fits into place, and it also has holes so that we can install a strap. And this strap ensures that instead of pinching the bucket to lift it, you can simply move your hand upwards.
For mechatronics features, we have an image capturing device. We're using OpenCV as our library, and so what happens is the camera here captures a frame. The system grayscales it, finds all of the black spots with a certain area, and counts those as dots, as you can see. And then in the system, we have 2 stepper motors. One is to release 1 die at a time up here. And then we have another stepper motor at the bottom for the 4-bar. This pushes the die away from the viewing area, and so that it's ready for the next one to come. And then for mechatronics features, we have an ultrasonic sensor and an infrared sensor. The way that our setup is set up, we have different stages, and so these 2 sensors make sure each stage is completed and make sure the dice went through the right passage. As well as we have 7 segment to display the dice number.
So for our wiring on the Raspberry Pi, we used up most of the GPIO pins that are available. So we have a button, we have the 7th segment, we have space for an agitator to help shake the funnel, but we ended up not needing it. We have a speaker, we have the 2 stepper motors, and we also have the 2 sensors, the ultrasonic sensor and the infrared sensor. All right, we'll quickly demo the project. So Jasmine's gonna hit the button. It's gonna dispense a die, it rolls out there. The camera is reading the value, and it displays the value. What's the value?
1.
And then the pusher on the bottom pushes it into the bucket. Right. So some challenges and some weaknesses of the project. One of the greatest challenges was that the dice indexer, getting that to release only 1 die at a time, so getting the fin shape was pretty difficult. And then also the mechanism on the bottom tends to get stuck because of the misalignment of the panels. Also, the camera detection requires a near black background, so having really consistent lighting is quite difficult. The sensors also, especially the ultrasonic sensor, has trouble working properly, so it's really inconsistent in terms of detecting a die.
And so we learned a lot about mechatronics throughout this project. Some lessons that we learned was that ultrasonic sensor was not the correct sensor for this application. Instead, we should have chosen either a laser beam break or a piezoelectric sensor. We've also learned that we could have looked into using an interrupter. One issue with the ultrasonic is that it switched between rotating the gear and the ultrasonic checking of the dice, which caused lag. And there was lots of lag in the Raspberry Pi because there was so many applications running with two motors and a camera all loaded on the Raspberry Pi. And finally, our greatest takeaway is that even though the components worked individually well, putting them together into the Raspberry Pi was very difficult. So we should have started that process sooner. And that is our project. Go for it.
Oh, you already did it.
It's a 4. It's a 4. Yay! And it's being pushed into the bucket.